couple of flavors of alignment. The simplest way to think about these is in terms of the rules for where you start and end in your alignment path. Let's see. So I'll just skip over. We can return to these kinds of things later. As I mentioned, the real basis for all this is that we're doing, if you will, log odds scoring. So that's really what we're computing inside these viterbies, but basically, for the purposes of implementing something like Programming Project 2, it's just you've got some scores and you add them. All right. So the different flavors of alignment. The flavor of alignment that we've been talking about so far is called global alignment. And it literally is what we showed on that heterogeneous profile HMM, where there was a beginning state, an end state, and we said we only allow paths that go all the way from the begin state to the end state. Another way of stating that condition in matrix terms, which hopefully will make it visual for you, is that we only allow paths that go all the way from one corner to the opposite corner. Okay? That's kind of equivalent. One way of thinking about that is that basically that means that the total score for a path that goes all the way from one corner to the opposite corner is that it scores, it includes a score component for every single letter in both sequences, in this sequence, in this sequence. We're not allowed to skip letters in one of the sequences without paying for that in terms of some scoring component, okay? So this is referred to as global alignment, basically because it means that we're aligning the global complete sequence of both sequences against each other. So for example, if you had one sequence really short and the other sequence really long, you're going to pay a huge gap penalty for deleting lots of letters of the long sequence in order to make it match up against the short sequence. Global alignment enforces that by basically requiring that the path can only begin and end at the corners of the matrix. So in terms of actual implementation, this is actually the simplest form of Viterbi sequence alignment, and I believe that's what you're doing in the programming project. Basically because with Viterbi, you fill out all these individual cells using the Viterbi algorithm, and then the question is, okay, well, what's the best endpoint? Well, in global alignment, there's only one possible endpoint anyway, which is this corner. So you already know what's the best possible endpoint. There's only one possible endpoint. It's that corner. So you just start traceback right there at that corner, and that gives you the optimal global alignment. Okay? All right. So there's the same thing in words on a slide. Basically means we have to go across the complete matrix all the way from the origin to the end. Corner m comma n, which allows for the possibility that the two sequences have different lengths, m and n. So